Hi there, my name is Ron Rogers, and this presentation is titled, I have done, at least, two really stupid things in aviation. And I'm going to talk to you about those. Now, this has to deal with aircraft takeoff, landing performance, and aborts. Now, this is a close-up picture of the abort testing done on the 777. And the 777, like a lot of the modern aircraft, has carbon brakes. And these brakes are extremely effective. And this is a dangerous test mission because you have the risk of fire, and of course you put a horrendous amount of energy into the brakes, and they become very hot. And carbon brakes have a great ability to absorb energy, but they get the tires hot, and then there's little blowout plugs on the tires if they get too hot, so they don't explode, because that would not be good. You could rupture a fuel tank, things like that. So the tires deflate, and I'll tell you, interesting, funny little, if you can call it that, story about deflating tires. But anyway, aborts have been a problem in industry. Now, you should be able to abort all the way up to your decision speed of V1. V1 is the speed for the runway and the thrust setting that will allow you either to continue the takeoff or to abort. Now, unfortunately, there have been a number of accidents, and the industry did an analysis, and they found out that, well, if you continued the takeoff in a lot of these instances where they otherwise did an overrun of the runway, you would have been a lot better off. You don't want to go off the end of the runway. That's just not a good thing. You can damage the aircraft, and a lot of times, unfortunately, these aborts were just not handled properly, and it kind of made the crews look kind of bad in that situation. Of course, there are times when you do not want to take it into the air, and the abort is very successful, and you have a very bad situation. You want to stay on the ground. But let me go back and give you just a little history. This is the first thing that I did that I considered was really stupid. Okay, this is back in my career, back in the late 70s. I'm at the Flight Test Center out at Edwards. Now, we've got the 15,000-foot runway at Edwards, and by anybody's estimation, that's a long runway. And the Thunderbirds were flying the T-38 at the time, and they'd had some problems with landing in some difficult situations. And Cheyenne, Wyoming was one of the incidents, and they decided to have a test pilot instruct the Thunderbirds on proper landing techniques, how to really get the most out of landing the aircraft. And Major Pete was the one who was doing this, and he wanted me to take over for him. I was the T-38 senior flight examiner at Stanival out at Edwards, and he was going to check me out on the various techniques he had developed, and then I was going to train the Thunderbird pilots to use these techniques. Well, in the meantime, the Air Force, in their infinite wisdom, decided that because I was getting a double master's in aero and electrical, they wanted to put me in charge of the F-16 flight control section out there at Edwards. And I go, great, I'd love to fly the F-16. And they said, no, it's a ground job. You don't get to fly. And I said, okay, I want to fly. We talked about it for 45 minutes, and it finally came to the needs of the Air Force, which, if you know about that term, it means you're screwed. So that started my airline career. Anyway, we get out on the end of the runway there. We get cleared for takeoff. We run both engines up to military power, which is 100%. Make sure both engines are working nice. And he says, okay, watch this, which is, dangerous words in any parlance. But he takes the number 2 engine and he pulls it back to idle. Okay. And he takes the number 1 engine and we release brakes and get it rolling just a bit. And he puts it into afterburner. And I think, okay, well, I didn't know that much about, I didn't have a multi-engine rating other than single line, center line thrust. And I didn't know about, we didn't have a VMC issue, and we didn't have issues like not having a lot of power. In all these, we had plenty of power, typically. So if you lost an engine at the normal place where you would continue the takeoff, you had plenty of power and you kept on going. Well, you don't lose 50% of the thrust, as any of you multi-engine guys know. You lose typically 80% of excess thrust. So, and especially from starting from a virtually stop position, this really becomes impressive. Okay, this was what I consider the first really stupid thing I did going along with this. So we're going down the runway and we're not accelerating like a T-38 typically accelerates, even with one in afterburner. So I'm going, yeah, this does make a big difference. And you see where that yellow arrow is. We became airborne at roughly 11,500 feet down the runway. Normally, we'd become airborne in at most 2,500 feet. So we're far down the runway, and we take off. Now, rotation speed, takeoff speed is 155 knots, and that's when rotate and become airborne. Now, you can't retract the gear until you get at least 165 knots. And normally, in a T-38 on the takeoff, you've got to get that gear up and the flaps up so fast that you don't overspeed them when you get to the gear speeds around 240 knots. So you got to get those things up right away. It's a real quick maneuver. Well, here we get airborne, okay? And I keep it in ground effect, just barely off the runway, accelerating, and it's really not accelerating very well. We actually go off the end of the runway before I get my 165 knots where I can safely retract the gear. Now, the problem on this 10 knots and why you need it is when you retract the gear, those gear doors on the center of the aircraft open, and they actually produce enough drag that the aircraft will settle back down to the runway if you have a thrust deficiency. So, okay. This is really cool. So we get the gear up. We continue to accelerate. Tower asks us if everything is all right. And we go, yeah, everything's all right. And I'm going, well, that was interesting. So we continue the takeoff. We fly around. We do the various maneuvers he wants to show me in the 38 on interesting landing techniques. And that was a lot of fun. Well, like I said, I was getting out of the Air Force. I'm going into the airlines, and I get involved very early because of my flight test background and that in doing a lot of volunteer work for the Airline Pilots Association, and I get to be I had a background in flight test at Boeing, and I'm end up being chairman of the Airworthiness Performance Committee and the New Aircraft Evaluation and Certification Committee, and they later combined the two committees. That's why I was chair of both of them. They had been separate committees, and they were combining them into the Aircraft Development and Evaluation programs. This has to do with aircraft design, evaluation, performance, and stuff like that. So aircraft performance was kind of my thing, and I was the director of that. Well, I'm going out for training. And this is the training center out at United Airlines. And they decided the industry was really pushing the danger of aborting. And they were coming up, the industry came up with this program. And it was called Standardized Computer Aircraft Performance, SCAP. Yeah, interesting acronym. There's another acronym very close to that isn't very nice acronym. But the acronym I think of is CRAP, because this was basically crap, and I actually wrote a paper to it, the airline, and we actually got it changed. But here was the deal. If you had a wet runway, we had what was known as V-speeds that you would use for like a wet runway because you might have trouble stopping. So they would determine a minimum V-speed that you could take off on a runway if you lost an engine and you were worried about stopping. Well, they decided to use this airspeed, this V-speed situation, and normally if we were taking off, and here's an example. I pulled up this data for the Frankfurt runway 25 center, and as an example here. But in this case, and it's applicable to the other situation I'm going to describe here. In this case, our normal V1 speeds with the yellow arrow there, they truncate the one there. It's 156 for V1, 163 for VR, and 166 for V2. Well, they've got minimum speeds here, V1 of 109, VR 154, and 159. Okay, so they're saying that you can choose any airspeed between 109 and 156 as your V-speed, and they want you to use that lower end. So I'm out in training out at Denver, and we're going to take off on 16 right. That's the program here, and we have similar speeds as I quoted there. And we've got a V-speed for this situation that's around 100 knots. Okay, This is reasonably ridiculously low speed because I'm barely down the runway. I've got a good, when we have this supposed engine failure, I've got roughly about 12,000 feet of runway. So I'm 100 knots down. I'm at 100 knots going down the runway. And okay, it's in the simulator, so we're going to play this game. And he fails an engine. And we keep rolling and rolling and rolling and rolling. And the instructor is real happy because this demonstrates that you can actually do it. We use that entire runway before we get airborne. Now, I have taken off on this runway before, and I have used the entire runway on a hot day with a full load when we were flying to Honolulu. I've flown the Denver to Honolulu flight. And of course, you may remember that there was an aircraft, a 777, that took off out of Denver and did have an issue with this engine right here. Now, let me show you something interesting. When I found out the nose number of the aircraft, I'm going, that really sounds familiar. Well, on my very last flight at United Airlines, see this yellow arrow? That's the same engine. It's in a lot better shape. This was a bit before they had that incident, and I was very glad because I had my family and kids, their wives and grandkids on this airplane, a total of 11 of them at the time, and my wife, and I was glad we didn't have to mess with that. But okay, back to where we were. Okay, we're back in the simulator on the 777. And like I said, I'm going down the runway, and this is going on forever and ever. And I use the entire runway. And after I do that, and I see how happy the instructor is that this thing took off after using the entire runway, when I could have easily aborted. I would have pulled off at probably that first high speed and taxied back with an engine failure. Taking it into the air at such a low speed, I thought was absolutely insane. And it was interesting. The company actually did refine it, and they decided, yeah, those speeds are too low. We're gonna take them up a good 20 knots or so. But like I said, Boeing has done extensive testing. The industry found that, average pilots, if you've seen my presentation where Boeing was talking about average pilots, quote unquote, sometimes have issues with the aborts, but the aircraft has great capabilities, and if you train properly, you can do an abort right up to V1, and I'll tell you about that in just a second. And it works quite well. I was involved in flight tests. Look at that. The hair's dark. It's not gray like this. I was involved in flight test on the 777 at Boeing. They let me fly several test missions. And the nice thing about these, you're not going to make any money with this few number of seats, but you got great instrumentation. And they go through all sorts of testing, high-speed aborts. Here's actually my group here when we went out on the 300. I'm up there at the upper left. There you can see me a little bit better out of focus. I'm in the far left there. The next three guys are on my committee. The guy in the blue jacket there is Frank Santoni. He's the chief test pilot on the 777-300 now. John Cashman next to him is now the head of flight test. He had been the guy that I was involved a lot with the 777-200 because at the time he was the chief test pilot. And they would bring this aircraft out to Edwards, and they would do all sorts of testings. They would put a little water trough there so they could see when the nose gear went through the water if it caused any problem flaming out the engines, because you really didn't want that if you were taking off on a wet runway. And they do the most fun test here. This is the VMU, the V of minimum unstick. And they use this for a lot of calculations on performance. And here it is. You notice that the gear is coming off and the tail is still on the ground. I never performed any of these tests. These are, again, a high-risk test. And they told me that, a line pilot can probably hit the tail without too much trouble when they're not trying to. But to get this thing where they actually were able to set the tail down without lifting off prematurely was not that easy. And they put this big railroad tie size piece of oak on there, obviously, so they don't damage the tail. But on an evaluation flight where I was out there doing a test flight with Boeing, the test pilot said, "Well, let's do an abort here for fun." So we accelerate to V1, and if you're an airline pilot, you've probably often wondered, like I did, that there's often not a whole lot of runway under that nose when you hit V1, and you go to yourself, will this aircraft really stop? Yes, it will. Uh, and in this case, we didn't have a whole bunch of runway left. It looked like about 1,500 feet or so. But boy, when you go into max braking in an abort, you stop really quickly, and we did. It was very impressive. But the industry has a problem with aborts. One thing, these brakes on these aircraft, they are impressive. On the 777, you've got 6 tires on each main bogie. And because the carbon brake wears the same on a rejected takeoff as just a normal braking, interesting, it grinds the carbon off, that they only stop, when you put the brakes on for a gentle stop on the 777, they only use 3. They go the front, the middle, and then the back. So they alternate the 3 pairs. And that was always fun. I would bring up that question in my orals, and it was always fun when I'd ask the instructor that question, because typically outside of Boeing, nobody happened to know that answer. But anyway, the point is that these brakes are extremely effective. Do not get up out of your seat early when the aircraft is coming into the gate, because you may only be going 10 miles per hour. But if my foot slips on that brake, this aircraft will be stopped in an instant, and anybody who's not belted will go flying. And let me tell you about an incident I had with a it wasn't even that high speed of abort, but it was interesting. I was going to Paris to go down to Toulouse and do some flight evaluations on Airbus. And at the time, United Airlines did not have much of a European contingency at all. Obviously, you can probably tell because Pan Am was in existence. So I get in JFK, and I'm going to jump seat on a Pan Am 747. And we go out, we get on the runway, and just as we're starting to roll, I hear a pop. And of course, this is the first time I've ever been on a 747. I don't know what's going on or anything like that. But as we're going down the runway, one of the other aircraft calls out that we'd blown a tire. Well, we were only a little bit over 100 knots, and that's not terribly fast, as far as what your normal V speed. The V speed was up there around 150 knots or so. So the captain elects to abort. We're not going that fast. And he just starts to do normal braking, and we're easing it back down. He actually, on the rollout, gets on the PA and tells everybody to remain seated, which is what you want to do, because you don't want them to start the evacuation as soon as stops. So he's actually talking about we had a situation with the tire, and we'd be going back to the gate while he's rolling on the runway. Kind of a little bit of a sterile cockpit violation at that point. But anyway, we pull off the runway. The fire department will not let us exit. Or not let us move any farther. They won't let us go back to the gate. And they had reason for that, because if it was a truly high-speed abort, which it really wasn't, at least in my opinion, but I was a not very experienced pilot anyway, but it didn't seem like a high-speed abort, but they weren't letting him move, so he was sitting there. And I look up at the second officer's panel, and there's the analog gauges with brake temperature, and they're just a little gauge that goes from left to right, and the brake temperatures are setting there in the green. Well, of course, little did I know that the brake temperatures will rise over time, because the heat is in the brakes, and it has to get to the brake sensor. So it takes a little bit. So we're sitting there, and the captain's arguing with the fire department about wanting to move to the gate, and I happen to notice that the temperatures are starting to rise, and they're going up. Well, they're out of the green now; they're in the yellow. Okay, they're continuing to rise through the yellow. Well, this is interesting, and they finally get clearance to the gate, and now the brake temperatures are up solidly in the red and still climbing. As we pull into the gate, we start hearing pops. The little temperature plugs in the tires start blowing, and the tires start to deflate, and you can actually feel the aircraft start to settle as all the tires deflate, and we pull into the gate, and then it just kind of settles there. Well, okay, fine. we were going to get served food, once we got going. This is around supper time. The flight attendant comes in and says, "Hey, they're going to get new galleys and all that stuff. Here, guys." And we had a big platter of shrimp. We started eating it, and all of a sudden, food service comes on board and says, "Well, you got a new airplane. We're moving all the food service over, so somebody in first class may not have got as much shrimp as they wanted." But that was kind of an interesting exposure to me to how bad even a reasonably low-speed abort could be. Well, like I said, the industry is pushing for the go decision, and okay, we need to use a certain amount of intelligence here. If you've got a bad situation, don't take an aircraft that is in a bad situation into the air, but don't use such ridiculously low airspeeds that you continue to accelerate for 10,000 feet down the runway. And one of my arguments was, and I used the data from the Frankfurt airport there, runway 25 center. I said, when I get to that 106 knots, if I have an engine failure, I'm only about 1,500 feet down the runway. I can easily abort. I've got at least 10,000 feet of runway ahead of me, and to continue in the air would be the epitome of stupidity, and they did agree with me. Anyway, that's my thoughts on abort. I hope you found it interesting, enjoyable, enlightening maybe even. Thanks for listening.